Today's lesson is a continuation of section 4.1, plotting points in a coordinate plane. So in the first part of this section, we kind of reviewed, well, how do I plot points or plot ordered pairs in a coordinate plane, and just kind of going over that, I'll do a brief review of that. What did we talk about? Well, I've got some points on a grid right now, and I'm going to find the coordinates of each of these points, so A, B, C, and D. Again, if the points are labeled, then yeah, usually I will keep that in my answer. So in this case, yeah, they do have letters by them, so I'm going to keep that with. Oops, and I want to move all this with me here. But when I'm looking at points, remember that I have an X and Y axis here. My X axis is my horizontal, my Y axis is my vertical. When I'm talking about ordered pairs, I'm always talking about an X and a Y coordinate. It's saying where on the grid is this point located. How far do I go? You can think of this first number as how far do I go left or right? How far do I go along the X axis? Do I go left or right in that case? And the second number, the Y coordinate, is, well, how far do I go from the origin? How far do I go up or down? So, again, those numbers can tell me where exactly this point should be located. 0, 0 is the origin, this point right here in the middle, so everything is based off of that. And again, you can think of it almost like a number line. Like as I go to the right for X, it's like 1, 2, 3, 4. As I go left, it'd be like -1, -2, -3, -4. Okay. So looking at some of these points now, and again, that is kind of a review from the first lesson, so if we're having a little trouble with that still, you can watch the previous lesson in section 4.1 here. But along the x-axis, point A looks like it's 1, 2, 3, 4, 5 spots left, and 1, 2, 3, 4, 5 spots up. So it'd be -5 for the x-coordinate because I went to the left 5, and then I went up 5 in the y direction, so it's +5 for my second number. So -5, 5, that's the point where A is located. Point B, for that point I haven't gone left or right, I've just gone up 2 spots on the y-axis. So since I haven't gone left or right at all from the origin, that means I've gone 0 left or right. So I'm still right at the origin, right on the y-axis. So 0 left or right, and just 2 up, so 0, 2 in that case. For point C, looks like I've gone 3 to the right and 4 up, so 3, 4 for the coordinates for that one. And kind of buzzing through these last two here, 1, 2, 3, 4, 1, 2, 3. For point D, I've gone left 4, so that means I got -4 for the x coordinate, left 4, and down 3. In the y direction when I go down, that's also negative, so -3. And point E, I've gone 2 to the right and 1 down, so 2 to the right on the x-axis means I've gone +2, down 1, so that means negative in the y direction, so -1. So they're my coordinates, or they're my ordered pairs for each of those points that are on the grid. Just a brief review of how the grid works and where we're looking to go for particular points. Well, as I've got up there at the top now, the next step is being able to graph an equation. So we're going a little bit ahead here. This goes into the next section, but we should start it now here. We want to go on to be able to graph equations. So let's say an equation like this, y equals 2x. Now, some students may say, well, we just did a bunch of work with equations already. We solved equations, right? In chapter 3, that's all we did. A lot of what we did is we solved equations, and we tried to figure out maybe like what x equals in this particular equation. So why are we now graphing equations is what I get from students sometimes. Well, now we're doing something entirely different, right? These are still equations, okay? Both these cases are still equations. So why are we doing something totally different now with this one as we did with this one? Well, I'll ask students this question in class and see if they can kind of realize and recognize, first of all, what is the difference between these two equations that I have? Yes, they are both equations, but there's kind of a big difference between each of these. And that's kind of the reason why one of them we solve, or typically one we're looking to solve, and the other one actually we're solving in a way too. We're finding out what the answers are for that one as well, just a different way, by graphing. Well, I'll let students look at the equations very carefully for a while, but if you look at them, after looking at them for a little bit, usually somebody can come up with, well, this particular equation only has one variable in it. It only has x, whereas this equation has x and y. And that's going to be our difference why we solve the first equation here, like the ones that we did in chapter 3, and the second equation, or the one we're going to work with now, this is why we graph this instead. And again, even that, we're trying to find the solutions, as I'll talk about, but I'll mention that in a second. Going back to this one, though. Again, in equations like this, when there's just one variable in an equation in algebra, typically we can solve that equation. We can find out what that variable stands for. What is the solution? So look at this equation. Y equals x, or 2x, sorry, 2x plus 4 equals 8. 2x plus 4 equals 8. There's just one variable in there, just x right here. Since there's just one variable in there, we can solve this equation and find out exactly what x equals. It has to be a certain number that makes that equation true, where I take 2 times it plus 4 and it equals 8. And so we practice methods like this, right? We subtracted 4 from both sides, so 2x equals 4. Divide both sides by 2, x equals 2. 2 is the answer that works in that equation. It's the one number I can put in for x, and it will make that equation true. So now why are these equations different? Well, now that I've got two variables, just kind of bringing this equation down here, y equals 2x, okay? Well, now this problem is a little different. And actually, what I'll do is I'll show you, I'm actually going to use that same equation I used over here. I'm just going to change it a little bit. Let's say it's 2x plus y equals 8, okay? Well, now just changing it to just a little bit different instead. 2x plus y equals 8. Well, in the first equation, the one we solved over here, there was only one answer. 2 is the only answer that works in that equation. If x equals 2, it makes the equation true when I plug it back in. But in the new equation, now that I've changed this and given a second variable y here, well, now if x is 2, yeah, y would have to be 4 to make this equation true. But the thing is, there are other combinations now. Well, now let's say instead, what if x is 1? Well, if x is 1, I could make y equal to 6, and that would be a solution. So this also makes the equation true. It's another combination. So far we have, I could put in 2 for x and 4 for y. I could put in 1 for x and 6 for y. I could put in 4 for x. 2 times 4 gives me 8 plus, well, 0. That would also work, right? So 4, 0, that's another solution. All these so far work, and there are a bunch more. So all these ordered pairs work. So realize now that I have an equation with more than one variable, I don't have just one answer like I used to have. I have more solutions. And when there are two solutions, if you're taking notes along with me, here's what I want you to write down. When there are two variables in the equation, our solutions are now ordered pairs. It's a combination of x and a combination of an x and a y that could work in the equation. So kind of like I've shown up here already, well, I had 3 possible answers that could work for that equation I made up right there. So next I'll go back to that original equation, y equals 2x, the one we had above. I'll look at that equation again and I'll ask students, well, let's find some solutions for this equation. Again, now that we know this equation has 2 variables, like we mentioned here already, we know that there are going to be more than one possible solution. Just like I showed in the problem above here. When I have 2 variables, well, now there's just more than just one answer. That's why these equations are a little different. So I can ask students, give me a couple of examples. What could be a solution? What could I put in for x? Take 2 times that and give me the corresponding y then that would make this equation true. Well, usually I'll get a couple different answers. I'll get like 3, 6. And this is how we list ordered pairs. This is how we list those answers, as it says, an x and a y. The number you put in for x and the number you put in for y. It's called an ordered pair for that reason. It matters what the order is. The x number, the number you put in for x, has to be first, and the number you put in for y has to be second. And that combination, in parentheses, is the ordered pair. It's a point that makes this equation true. So 3, 6 would work. 2 times 3 gives me 6. And I'll ask for a few more answers. Well, usually they can give me 4, 8. Or they can give me even 0, 0. Or 1, 2. Or 10, 20. I mean, there are many answers. And then I'll ask them at this point, well, how many possible answers are there? And what we'll usually find out is, again, like I was kind of talking about above, in this equation we used to do in chapter 3, there's only one possible answer because there's only one variable. But now, on a problem with more than one variable, there's an infinite amount of solutions. There's an infinite amount of answers. And as I could list these, I can keep on listing more and more of these all day, but there's an infinite amount of these possible solutions. To graph an equation, we're just going to pick out a few of them, and that'll help us make the graph. And so how we usually organize these, you can list them like this as well. Ordered pairs with parentheses around the numbers and a comma in between. You can list ordered pairs like that. But what you'll often see in the book, and what I'll often do here also on the board, is I'll put them in a table. And that's just another way to represent them as well. All those ordered pairs I listed up there. 0, 0. This is just another way of saying I put 0 in for x in this equation, and I got 0 out for y. So that's just another way to say it, just like I put up here for 0, 0. That means the same exact thing. Just another way to organize all our points. So 0, 0, 1, 2, 2, 4, 3, 6, 4, 8. Again, I listed a bunch of different points. But there's some right there, and there's a way you can organize them. Well, again, those are ordered pairs. Those are like points. All these ordered pairs are solutions to this equation. And I can plot those solutions to help me make a graph of what the equation should look like. So again, if you're taking notes along with me, something else I'd like you to jot down. All these ordered pairs we found, they're solutions to the equation. They make it true. Again, like the one above, there's only one solution. Well, now that I have more than one variable, there's many solutions. And a graph, what does it do? It's a nice visual way to show all the possible solutions, as we'll find. So I'm going to make a graph of this equation right here. This one we did. Y equals 2x. If I look up there, there's some of my points, right? 0, 0. We started plotting points already in this section, so we know where 0, 0 is. We know where the point 1, 2 is. I can plot some of these. The point 1, 2, go to the right 1 up 2. The point 2, 4, to the right 2 up 4. The point 3, 6, right 3 up 6. The point 4, 8, over 4 up 8. I can plot all those points. And then graphing a line is when I draw a line through it. I draw a line through all these points. This is now showing all the possible solutions that fit for this equation. I think I kind of tailed off. I'm going to try to draw a nice straight one here so I can show the rest of what I want to show you as well. But hopefully that's a little better. But that's the graph of that line. And as long as I have a few points, I can graph that line. They should line up nicely. Whenever we're graphing linear equations, I should end up with a nice straight line. The word linear itself, the first 4 letters, L-I-N-E, forms the word line. And that's what happens in linear equations, is you always end up with a straight line graph. That's what we're looking for. Now again, I used just a few points there. I used 0, 0, 1, 2, 2, 4, 3, 6, 4, 8. I use all those points to help make my graph. And you only really need a few of them to do that. I actually really only need 2 points to make a line, but I'll always have you try a few just to make sure your points line up. But again, to prove that this line is showing us all the possible solutions to this equation, I'm going to think of another one that we didn't think of yet as a solution to this equation. Let's think of like a negative number, like the point, well, let's say -2, -4. If I put -2 in for x, 2 times 2 gives me -4. So this would also be a solution to this equation, right? Again, going into what does this graph show us? What does the line show us? It's all the possible solutions. So if I'm telling you this is also a solution, -2, -4, it also should be a point that this line goes through. And I'll go over here, -2, we left 2, 1, 2, and then down 4. And there's that point. If I had drawn it a little straighter, as you can see, it would go through that point. And do a great job of drawing it very straight. This is why you'll always use a ruler when you're graphing, but if I drew it nice and straight, you would find that here's the point. -2, -4. And yeah, the line does go through that point as well. I could think of more solutions as well. -3, -6. Left 3, down 6. There would be that point. And now my new line that I've kind of drawn a little straighter. This one right here, this bottom one. That one would go through that solution as well. Again, that's what the line is showing us. It's showing us all the possible ordered pairs that work for this equation. Any combination that works for this equation should show up on that line. And one more thing I mentioned earlier with it. We talked about, well, how many solutions are there for this equation? There's an infinite amount. Well, that's why we draw these arrows on the end of each line, because we're saying this line goes on forever in both directions. There's an infinite amount of points that would work for this equation. So if I kept this line going and going forever and ever off the grid, I would find more and more ordered pairs, more and more solutions to that equation, y equals 2x. So a lot of that is kind of the why or how does it work, but what am I going to want you to do? Well, sometimes in a problem, they'll ask you, they'll actually give you what the x coordinates they want you to plug in are. So, and that's what we'll work on here today. Is this particular problem, again, it gives you a table. It wants you to plug in these x values and find out what would be the corresponding y values that make this equation true. In this case, we'll just go to y equals 3x. So another simple equation, but y equals 3x. I'm going to plug those x values in, see what would y have to be to make that equation true. Well, if I put negative 1 in, negative 3 times negative 1 would give me, well, y would equal negative 3. So I'd get negative 3 for this one. So if x is negative 1, y is negative 3. If I put in 0, 3 times 0 just gives me 0. So if I put in 0, I get 0. That's the combination that will work for that equation. If I put in x for 0, y has to be 0. If I put in 1, 3 times 1 gives me 3. So I'm just kind of showing you how these numbers work. If I put in 2, 2 times 3 gives me 6. If I put in 3, 3 times 3 gives me 9. Okay. Often what I'll have you do, this particular problem wanted us to plug in 5 different values for x. Usually I'll just have you plug in 3, and it doesn't matter what 3 you plug in. Usually as long as you plug in at least 3 points, that'll work for me. You really only need 2 points to make a line, but if you plug in 3, it's kind of like a way of checking to make sure that the points you plugged in so far work. If you plug in 3 and all of a sudden you get something where you get 2 points like this and 1 off to the side, well, again, that we shouldn't get any kind of triangle shape like I talked about previously. Linear means we get a straight line for the graph. So if you get some kind of weird shape, well, that means we got to go back and check what we plugged in, make sure we did it correctly. So this particular problem, they'll want us to plug in 5 points. We'll plot those. Negative 1, negative 3 will be down here. 0, 0, 1, 3, 2, 6, 3, 9. I plot those points and use a ruler. Always use a ruler when I'm graphing linear equations. I'm going to use the ruler to draw that line. That line would show all the possible solutions that work for that equation. Again, I could pick out one that we didn't have up here. Let's say if I plugged in negative 2. Negative 2 times 3 would be negative 6. Just seeing if that's a solution. It is a solution. So seeing if that point is on the line as well. 1, 2, I'm going to go left 2 and down 6. 1, 2, 3, 4, 5, 6. And again, if I draw a perfect line, I would see that yes, it goes right through negative 2, negative 6 as well. So kind of our introduction to graphing equations is this first method where we find some ordered pairs. I can put them in a table like this, find some ordered pairs, plot those ordered pairs, the solutions to the equation, and use that to graph a line through those solutions.